Hello class, it's Mr. Kablan here, and today I will be presenting the final lesson for this chapter, which is going to be dealing with midpoints and diagonals of quadrilaterals. So in the last lesson, we looked at midpoints and what were called medians for triangles. This approach to this is relatively similar. The only difference is that we will be dealing with something called a diagonal, which is only going to be used for quadrilaterals or four-sided figures. So let's get straight to it here. And as I said before, just to talk about some of the things that we did in the previous lesson over here. So we did discuss with a midpoint. And again, a midpoint is a point, okay, that cuts a side into two equal lengths there. Now, remember with a triangle, we learned what was called a median, okay, which was a line that extends from one corner of the triangle to the opposite side of the triangle, and it cuts that opposite side in half. Okay, so when it comes to quadrilaterals don't have medians. They have what are called diagonals, and we're going to explore the relationships that exist with that. So remember what a quadrilateral is any four-sided figure. So what we have here, again, when we're talking about midpoints inside a quadrilateral, is that if you take a quadrilateral and as you can use, we're going to use this example over here. And if we draw a quadrilateral where all four side legs are going to be different, okay, when you join or create a midpoint, okay, again, which is a point on each side length there that cuts each side length there in half, okay, what's going to form inside here is a parallelogram, and that applies itself for all quadrilaterals. So remember what a parallelogram is, okay, is that you have opposite sides that are parallel, meaning they will never meet, and they'll also have the same side length here. So if you just use this example here, the one with the single arrow going to the top right here, so this side over here, as well as the one directly across from it, okay, are parallel, and they're also the same measure. Now, on the other end here, over here, notice that we have the one with two arrows. So this side length here and this side length over here are also the same and going in the same direction, meaning they'll never meet. So those pairs are also parallel. Now, again, with a parallelogram, this does not necessarily mean that the four side lengths are equal. Okay, so again, don't base it on the diagram that you see there. Just know that opposite sides are parallel and the same length. All right. Okay, and that's why inside of a quadrilateral, you will always have some sort of parallelogram. Okay, and what you need to know about it is that once you have a parallelogram, okay, the diagonals, meaning when you go from one corner to the opposite corner, they are going to bisect each other, and then they're going to cut itself exactly in half. So for example, this first line over here, which starts off from the top left to the bottom right, that would be a diagonal. Now, what you need to know about that here is that when it goes straight across, okay, and you draw the next one there, okay, you're going to see that the side lengths between this half over here and this half over here will be exactly the same. Same token with this one. Okay, notice that when we have a diagonal that cuts across over here, you know, so we have two side lengths that are also going to be equal. Okay, so that exists for diagonals of a parallelogram. All right, and we're going to see the relationships between them once we take a look at some numbers here. All right, so for the first part of here, what you can see here is a parallelogram. And what you also have here is knowing the fact that line segment A to E is 10 meters and line segment D to E is going to be 8 meters. Okay, so we're gonna look at it using when we're answering these questions here. So for part BE over here, okay, you can see that BE is this line over here, okay? So when you're looking at BE, we also have to preserve the direction when we're looking at the line as a whole here. So if you take a look at line BE over here, okay, you're going to see that it's going to be the same length and again in the direction as D to E. So even though the two arrowheads are facing each other, I'm doing this just to preserve the direction here. All right. So what we know about BE, it's going to be the same length as line DE. So BE here is going to be 8 meters. Okay. In a similar fashion, we have line segment CE. Well, we know that CE is part of the line that makes up A to C there. So C to E is going to be the same length as A to E. So that's going to be 10 meters. All right. Now, as I said before, that holds true because when these two diagonals cross each other inside a parallelogram, Okay, they bisect each other lengthwise, so where the two lengths would be equal there for the diagonal. So for A to C over here, we're now looking at this entire length here. So you can see here that when you're looking at A to C, we know that A to E is 10, and then C to E is also 10. So what we're going to see here is that the entire length of A to C is going to be 20 meters. Okay. In a similar fashion, we're going to look at B to D, which is straight across. So we know that B to E is here is going to be 10 or 8, sorry, and that will tell us that D to E is also 8. So the total here will be 16. All right. So again, everything is based on a factor of 2. All right, next one over here. We're now going to just identify the parallel lines. And the main thing I just want to get across here is that when we're looking at parallel lines, and we do have to keep in mind that we also have to preserve the direction here. So we'll start off with the first one here. Okay, we know that WXYZ, which is the parallelogram inside the quadrilateral. Okay, remember the quadrilateral in this example here is D, E, G, and F. Okay, and all four side lengths are different. However, when you connect the midpoints of those four lines there, what you have there will be a parallelogram. Okay, so the opposite sides will be parallel, as well as having the same side length here. All right, so what we want to do here is just to identify the corresponding side simply by looking at the letters in the direction. Okay, so for example, if I'm looking at WX, okay, keeping in mind that we have to preserve the direction of the parallel line to it. Okay, so notice I'm very specific when it comes to the order of the letters. So if we're looking at WX, okay, the corresponding side to that, or the side that is parallel to that, is going to be ZY. Okay, make sure you don't say YZ because you would have that's in different directions there. Okay, so that's going to be our first set of parallel lines. And if you look at XY, okay, the parallel line to that will be WZ. Okay, and that's pretty much it. All right, so that not only concludes this chapter, this lesson, but it also concludes this chapter. So for the remainder of this chapter here, continue working on the review, and I will see you in the next chapter.